Hello everyone, this is second lecture of change of axis in which we discuss the 2 points. The first point is translation of axis where we shifted the origin, and the second point is rotation of axis. So this is today's lecture related to rotation of axis. Okay, so in which we change the direction of axis. Let us see. First, we trace the diagram. Now this is the x-axis, y-axis. Okay. This is origin. Now P be any point. There are two P points. Okay. The first P point associated to this origin with respect to the axis OX and OY. Okay. The x, the small x is a distance O to M and small y is a distance P to M. Okay. Now we rotate this axis through an angle theta in anti-clockwise direction up to this point. And we consider the same point, but the axis is changed. Axis is changed. We rotate the original axis through an angle theta. The new axis is OX dash and OY dash. And we consider the same point, but its coordinate is changed. Now the distance from O to Q we consider as a x dash. Okay, and this is a perpendicular line P to Q, okay, which is parallel to y dash axis, whose distance we consider as a y dash. Okay, now see, let OX and OY be the given axis of the coordinates, and OX dash, OY dash are any two perpendicular lines through the same origin inclined an angle theta with respect to OX and OY. Now the first P point we already discussed, the small x distance, and this is small y distance. Small x means O to M and small y is P to M with respect to OX and OY. Okay. Now the point is fixed as it is P point. Only we change the axis. Then the new distance of P associated to OX dash and OY dash is small x dash, small y dash. I repeat again, small x dash is O to Q distance and small y dash is P to Q distance. Okay. Now from figure, the PM, line PM is perpendicular to OX. And see, this is the original axis. After rotating axis through an angle theta, that time the PQ is perpendicular to OX dash. Okay. Now the angle X dash O dash is same as, see, this is the X dash O to X. X dash OX is same as angle MPQ. See, this is the M point, this is the P point, this is the Q point. Okay. Why these are the same? Because the angle between the lines, equal to the angle between the perpendicular line, this one and this one on the line, means on the axis OX and OY dash. Okay, now see, OM is X distance and this perpendicular line to the OX whose distance is Y. Similarly, OQ is X dash distance and PQ is Y dash distance. Now let us find the X and Y. Okay. First we find the X. X is equal to O to M. O to M. Now it can be written as O to L. O to L minus m to l. We subtract this distance from OM. That is the OM. We get the required distance OM. Okay. Now we keep OL as it is. And we write the, instead of ML, we write the RQ because we want the side associated to theta, and RQ is parallel to ML. RQ is parallel to ML. Both are the same. Okay. And see here, the RQ is associated to this theta and OL is associated to this theta, first theta. Okay. And both are the same. Now here we use the formula cos theta is equal to, suppose now this is A, B, C. This is a perpendicular, and suppose this is the theta. Okay. Then what is the cos theta here? Cos theta means what? Adjacent side. Adjacent side divided by hypotenuse. That is PC. And sin theta is equal to, sine of theta is equal to opposite side. What is opposite side? Is AC divided by hypotenuse, that is the PC. Now see OL. OL is equal to OL, which is adjacent side for this theta. It can be written as cos of theta is equal to OL divided by the hypotenuse. So what is the hypotenuse for this angle? Is OQ. Is OQ. Okay, that OL is equal to OQ is multiplied here. OQ is multiplied here, that is OQ cos theta. Okay, OQ cos theta. Now RQ. Now for this RQ is opposite sign. Opposite sign, that is sin theta is equal to opposite sign RQ divided by hypotenuse. Here hypotenuse is PQ. PQ. That's why the RQ is equal to PQ is multiplied. Now see what is the length of OQ? From diagram, the length of the OQ is x dash. So we write here x dash. And what is the length of the PQ, which is y dash? It can be written as x is equal to x dash cos theta minus y dash sin theta. We find the x. Similarly, we find the y. Y is equal to the MP distance or PM distance. Okay, now it can be written as M to R plus R to P. Now R to P is associated to this theta, but M to R not associated to this theta and this theta. So now the M to R is parallel to this LQ distance, and LQ is associated to this theta. This is the opposite side. So instead of MR, we write the LQ. Okay, and we use the same formula, that is LQ is opposite side, that is the sin theta is equal to LQ divided by hypotenuse OQ. Okay, that is OQ sin theta, and RP is equal to adjacent side, that is the cos theta is equal to adjacent side divided by the hypotenuse PQ. That is PQ is equal to, RP is equal to PQ is multiplied to the cos theta, PQ cos theta. Now see, what is the distance of OQ? The distance of OQ is x dash and the distance of PQ is y dash. So we get the formula x dash sin theta plus y dash sin theta is equal to y. Okay, the equation 1 and 2 are called the equation of rotation. Okay, and our aim is to find the equation of rotation. Okay, now from equation 1 and equation 2, we can also find the value of x dash and y dash. How we can find the x dash and y dash? Suppose if you want to find the x dash, then we have to eliminate the y dash. The coefficient of y dash in equation 1 and equation 2 different. Okay, then we multiplied here cosine term, we multiplied here cos theta, and here multiplied here sin theta. Okay, that is cos into sine minus sine, and here cos into sine plus sine, and when we take its addition, then cos, then second term is cancelled, that is y dash is element, here cos square, here plus sine square, okay, which is x dash is common, cos square plus sine square is 1, and we multiplied here cos, that is x cos theta plus y sin theta in this way. Similarly, we can calculate the y dash also. Okay, now here equation 1 and 2 we can also write in a matrix form. How we can write equation 1 and 2? See, this is xy is a vector, x y is equal to, now this is the linear equation, that is the coefficient of x dash y dash, these are the first row, cos of theta minus sine of theta. Now this equation number 2, the first row is sine theta, okay, and cos of theta into the coefficient of sine and cosine, okay, that is x dash y dash. Now this is a matrix form, okay, and this matrix is called as an orthogonal matrix also. If we check its determinant, we get the +1, and which is also called as a rotational matrix. Okay, now see, we can also verify this is the circular equation. Okay, this is the circular equation, x dash y dash and x and y. If we apply the distance formula here for the original axis and apply the distance formula for the new axis ox dash and oy dash, we get the same thing. How? See, so here if we square equation 1 and 2, then what we get? X square plus y square, and here the a minus b bracket square, then here x dash square cos square theta minus 2 times ab, 2 times x dash y dash cos theta sine of theta plus y dash sine square theta. Okay, and plus this is x square. Okay, now for y, so here this is equation 2, we squaring here. Okay, that is x dash square sine square theta plus 2x dash y dash cos theta sine of theta plus y dash cos square theta. Now add this, the middle term is cancelled, second term. Okay, here x dash is common, x dash square, and cos square plus sine square is 1. Here y dash square is common. Okay, and remaining term sine square plus cos square is 1. So what we get? X square plus y square is same as x dash square plus y dash square. Okay, so this is what? This is nothing but the distance. It means what? The length of the OP remains unaltered by rotation of axis. Okay, now let us take the example on this topic. The example is, find what equation x square plus 4xy plus y square is equal to 0 become when the axes are turned through an angle 45. Okay, it means we rotate the original axis through an angle 45 degree. That time what the equation? Okay, so here for rotation the angle is given, and we find the value of x and y. Those we discuss in this point. We find just x and y here, and it requires the only theta, and theta is provided here. That is solution. Theta is equal to 45 degree. 45 degree. The equations of rotation. The first equation is x. x dash cos of theta minus y dash sine of theta. Now put the value of theta, then we get x cos pi by 4 minus y dash sine pi by 4. So we know that cos of pi by 4 is same as sine of pi by 4, which is 1 upon root 2. That is here 1 upon root 2, here 1 upon root 2. Root 2 denominator is same. Then it can be written as x dash minus y dash divided by root 2 divided by root 2. It can be written as x dash minus y dash divided by root of 2. Now similarly find the y. Y is equal to x dash sine of theta plus y dash cos of theta. Okay, now put the value, that is x dash cos pi by 4 plus y dash sine of pi by 4. That is y is equal to x dash root 2. We put the value of pi by 4, y dash root 2. Denominator is same. That is x dash plus y dash. Say equation 1, equation 2. Now the given equation, since the given equation x square plus 4xy plus y square is equal to 0. Now put 1 and 2 in equation 3. Substitute here the value of the x. We substitute value of x is x dash minus y dash divided by root 2 its square plus 4 times x dash minus y dash divided by root 2 x dash the value of y plus y dash divided by root 2. Now plus the value of y is x dash plus y dash divided by root 2 its square is equal to 0. Now here root 2 its square is second term root 2 that is 2, and third term root 2 its square, that is throughout denominator is simply 2. So I am taking 2 is common, that is 1 by 2. Now the remaining numerator is a minus b, as like a minus b bracket square, and we know a minus b bracket square is a square minus twice ab plus b square, and this last term is a plus b bracket square, a square plus twice ab plus b square, and the middle term as a minus b, a plus b, that is a square minus b square. We apply the formula here, that is x dash square minus 2 times x dash y dash plus y dash square. Okay, plus, sorry, plus, don't complete the square bracket here, plus 4 times x dash square, that is a minus b, a plus b, y dash square. Okay, now plus here x dash square plus 2 times x dash y dash, we apply the second formula, and plus y dash square. Now here plus 2xy dash minus 2xy dash plus 2xy dash is cancelled. Now 4x dash and this 1 and this one, that is 6. 1 by 2, 6 times x dash square. Now here 4 minus 4 y dash square and minus 4, and this is 1, 2. Okay, that is the 4, the minus 4 and 1 and 2 plus 2, that is minus 2 y dash square is equal to 0. Now 2 is divide, so we get 3x dash square minus 2 cancel here, y dash square is equal to 0. So which is a required equation when we rotate the original axis through an angle theta. Okay, thank you.